Hello everyone, I'm back with another interesting video of networking concept part 2. As we have already gone through with the networking basic part 1, if you missed that video, you can just find this video in our channel. So let's start with our networking basic part 2. In this slide, we are going through with what is OSI and TCP IP models, local area network that is LAN, and WAN that is a wide area network, and encapsulations, Ethernet explained, and Ethernet frames. So let's start with the topic 1, that is OSI and OSI their model. So what is OSI? OSI is an open system interconnection. It's just a reference. It tells the people the how a data is translated from one computer to another computer, or how the data is transferred from one PC to another PC. It's just a concept, or it's just a reference model we're using in the OSI. So in OSI is developed by the ISO, it's the International Organization for the Standardization, and of course it has some protocols, the how the data transform from top level to level 1. So we have a 7 layer in OSI, and we can perform within, first of all we have as a application layer. The work of the application layer, we can see that it's a work of interaction, the how we can interact with our PC. If you open any browser like google.com, facebook.com, or gmail.com, what appears in our screen, that is the interaction part. So this is the part comes in the form of application layer. The application layer is performing the task of their interaction. The second, we have a presentation layer. The task or responsibility of presentation layer is to define the format of data. If you're seeing our browser, we have different videos, we have a text, we have images, we have a GIF images. So these formats are be defined, or can be task is responsible by presentation, because presentation is responsible for their format of their data. Can be an audio, it can be a video, it can be an image, it can be any HTML form. So this is a task performed by presentation. Next we have a session layer. Of course, if one using the 2 or 3 browser, we are using each browser with the individual, their separate browsers, such as we are using the Facebook, Gmail, Yahoo.com. So these 3 sessions are divided by a session layer by their managing, and also create the session, it's manage the session, and it later on it terminate the session when we close the browser and we disconnect with. So this is the task of the session layer. Next we have a transport layer. The transport layer plays a major role in OSI model because it provides end-to-end delivery of your data and your packets. It gives you assurance your data has been transmitted and been reached the point you want to access. So it provides the end-to-end delivery. This is the part of your transport layer. Next we have a network layer. In network layer, the IP address taggings are performed. It will take your IP address and the whom you want to send your data or packet in the network. It check the both IP addresses from source IP to destination IP. So this tagging is performed in our network layer. So later on we have a data link layer. The data link layer, as we perform the task of IP addresses, and the same way data link layer perform the task of MAC address. As we know, the MAC address is unique for each and every devices. So with MAC address, we can send our data exactly at that location to whom we want to send by using the MAC address. If we check the MAC address of source, and also check and also tag the MAC address of your destination. After that, we have last layer, we have a physical layer. Of course, the physical layer plays a big role, because in the physical layer we are using the hardware devices. Can be a cable, can be a Ethernet, can be a hub, bus. So these all are concerned with our OSI model. From top to bottom, we have application, presentation, session, transport, network, data, and physical layer. So this is all about the OSI. And as we have seen that how the task and the perform, we can see the applications is using responsible for the interactions or for the interface, and presentation layer will define the format of data. Session layer responsible for creating, managing, and establishing, and of course terminating the session. And transport layer will provide the end-to-end delivery of a packet. Can be a TCP or can be a UDP. In network, we just perform the IP address tagging, check the source and destination IP. In data link layer, it goes through with the MAC addresses, source and destination MAC addresses, and physical layers. It can be a router, switch, hub that deal with the cable. So this is all about the OSI model. And of course, like OSI, we have another one that's a TCP/IP. It's a transmission control internet protocol. And this is a two network standard that define how is data transferred from one PC or one computer to another computer. As we know, it's created before the OSI model by the DARPA, that's a Defense Advanced Research Project Agency. Just like OSI model, so it's also described his layers, but as in OSI it's a 7 layers, but it's divided in 4 layers. The layers we divided in TCP/IP, that's application, transport, internet, and network access. So these all layers are, as we are performing the task, as we have seen in the OSI, so each layer has their different task. Or we can say the OSI model, in these steps we need to transfer data over the network flow in very specific manner, but in which we define our protocol used in the layer and how the data is transferred. It's also in OSI which prescribe the TCP/IP model described related to TCP/IP models. Now, we have gone through with the LAN and of course with WAN. So these two types of network, this is the most common and famous. It can, but later on we can add it just like a CAN, campus area, can add it the MAN is a metropolitan area, but LAN and WAN, these two plays a big major role in our network. So we can see in the picture when the two computers sharing their data resources, they're using their switch, then goes to their router and goes to the internet. And the reverse order, when the internet send it data to router to your destination PC, and the router will send it to your specific by your ISP to your computer. So the LAN is local area network, but in our form of the internet, we're sharing a one computer to another computer. So this is the concept of basic LAN in internal form, the limited area or within a limited building. But if you're talking about the WAN, this is the structure of the WAN, the how is data transferred from one city to another city. This comes in the category of WAN. Of course, we are using multiple, we have a people who are residing with their multiple cities, countries, but in this scenario, we have three cities like Delhi, Mumbai, Chennai, and when the Delhi wants to connect with the Mumbai department and the Mumbai department wants to share their resources to the Chennai departments, and they all can share their data and resources using a WAN technology. This is the wide area network. All computer and all internet and all ISP are connected with each other by using a WAN network. So next we have an advanced one, that's an encapsulation. The encapsulation, it can be related to a specific in your IP address. In the IP address we have a different form. We have a headers, we have TCP headers, we have a IP headers, and data and frame tailors. So what is a frame? Frame is nothing, is a encapsulated data that is described by your network access layer. In same way we have a segmentation. Segmentation is encapsulated data that is defined by your transport layer, and we have a packets. Packets can be encapsulated data, can be defined by your network layer. In packet we have a IP of their source and their destination. In general, we can say the term encapsulation is a process of the adding headers, IP headers, TCP data, and frames in tailors. Can be if suppose you want to send an email, the work from start from the OSI from application layer to transport layer, and the application layer, when the data is sent to transport layer, then transport layer encapsulate that data and further is sent it to next layer. So on, the next layer will perform the same task. It encapsulated that data and further pass on to your next layer. So this is how the data is goes from in OSI model from top to bottom or bottom to top. On same way we have data encapsulated in OSI model. We have a difference. There's a PDU. That's a PDU is a protocol data unit. As you can see from the layer 7, layer 6, 5, 4, 3, 2, 1. That's a OSI models layer. Application, presentation, session, and further on data, network, and go on. So we can say the PDU of the process protocol data unit of Layer 7, L7 PDU is data. From L7 to L6 we have following the data. L5 data, we have a different headers of their PDUs, and we can say in the TCP/IP model, term like a segments, generally packets and frames refer to data but described in a particular layer. So we can say this is a PDU, that's a protocol data unit from in OSI model from top to bottom. And we have another word we have gone through in this chapter. We have Ethernet, how we explain the Ethernet. This is the most used in technology in networking nowadays. Today we are using this technology. It's a vast technology increasing day by day. And Ethernet is described by the IEEE 802.3 as a 802.3 stands in the use of the CSMA to avoid occlusion detections, so the traffic cannot be collision in a very simple network. To avoid the detections of the occlusions, we are using the IEEE standards. And we have Ethernet frames. In frames, we have SFD, we have destination MAC, we have a source MAC, we have a tabs, data, pads, SFCs. In short, we can describe SFD as a start frame of the delimiters, and the source MAC address, that's a MAC address of your source to whom you want that data send it from. The destination, the computer, the destination computer to whom you want to send your data. So this is the Ethernet frame, as we can see, then defined in a single scenario. It's Ethernet defined by the IEEE 802.3 Ethernet frame, and their specific descriptions you can see in the frame pictures. It is the can be a data, can be a pad, can be a FCS. So later we'll discuss and with all this in advance in our next slides. So this is all of you. For thank you for watching this video. I hope you like this video, and see you next time, and have a nice day.